This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Akshay Manchale. My guest today is Ashley Peacock, and we're going to talk about diagramming in software engineering. Ashley is a staff engineer and architect working in the UK tech industry with over 10 years of experience. He has experience across the tech stack with particular focus on backend technologies. He's an avid user of diagrams and a huge advocate for the power in conveying ideas, documenting architectures, and whiteboarding problems. He's the author of the book, Creating Software with Modern Diagramming Techniques. Ashley, welcome to the show.
Thank you very much for having me. Glad to be here.
To get started, I want to get a sense of why you think diagramming is important. In other forms of engineering, diagramming may be a requirement. If you're a civil engineer, maybe you're adding diagrams as a requirement by law. But in software, it's not so much so that it's required. It's a nice to have. But I know you're a huge advocate for diagramming. So why do you think it's important, and why don't we use it more often?
I think the power from a diagram comes from the ease with which it can make information digestible. So I'm sure you've experienced someone send you a document to read, and you've opened it up, and it's just a huge wall of text. And the chances are you either left it in the tab and thought, I'll read that later because you don't want to read it, or you read it and you skim read it, you don't read it properly. But it can just be really hard to digest, just a wall of text. Or if you're at a conference, there's a reason that you have slides for a conference speaker. It's because there's something on the screen for you to read, something you can digest that's easy for you to digest. Now, if you talk about software engineering, documenting your architecture or explaining something to someone with some sort of visual diagram, that can really help them to understand the problem, understand your architecture, that kind of stuff. In the company that I work for, it's got to the point now where I hate to use the word famous, but I'm slightly famous within the company that I work for diagramming, to the point that people find it so useful and so much easier to understand problems and information. I would go to meetings, there wouldn't be my meetings, and they would be like, oh, I'm sure Ashley's got a diagram that can explain this to us. And obviously I did not have a diagram available to them because it wasn't my meeting, but it kind of shows the point of they weren't necessarily used to diagrams, but once they saw the power in them, they were much more open to them. And another example, my CTO at the time, he kind of shouted out one of the diagrams I used because he wanted people to use diagrams. He'd seen the power of diagrams, and I'd create a rather large system design kind of architecture document. And it really kind of pushed my career forward because I was able to express myself through diagrams, my ideas, my proposals, and I can make them digestible for anyone that wanted to read those documents.
Yeah. You make a great point that it's good for communicating ideas, and I think it makes it easier for the readers. From a writer perspective, at what points do you use diagrams in general software engineering life cycles?
So I split diagrams into two types of diagram. I call them kind of short-lived diagrams that are more ad hoc, and long-lived diagrams that you want to typically commit along with your source code. So the short-lived ones are used during a brainstorming session or during pairing to help explain something to someone. So if we're pairing together and I'm trying to explain to you the problem we're trying to solve or a piece of code, for example, I can just quickly whip up a diagram to help explain that. If you're not quite understanding what I'm saying with my words, I can try with a visual approach instead. It's not always required. It's something you can reach for, like an extra tool in your tool set that you can help explain things to others easily. And the long-lived side is the stuff you put along with your source code in your repository. And that will be things like your architecture. So anyone who wants to understand about a given system's architecture, there should be a place they can go, they can read that document and understand at a glance, rather than reading a huge wall of text or relying on asking someone who's got information in their brain. They can just go read it. That's a really common one.
Mm-hmm. I want to get a sense of why you think people don't use it more often. There's a clear usefulness to it when you're the reader and you're the consumer. For any sort of software architecture that's represented in a diagram, makes it simpler, easier to understand, but we don't really use it as often. So what's the friction here?
I think there's a few different factors that go into this one. I think some of it is there are older technologies or older standards, one of them being UML, which stands for the Unified Modeling Language. It was kind of created in the 90s as a way to standardize creating software diagrams. And I think it's kind of got a bad reputation. They made some maybe choice decisions. I think they tried to make it almost too standard and or too restrictive. They wanted things done in a certain way rather than focusing on the power the diagram could bring. They focused on the notation, for example, which is not so important. So I think people have got used to hearing from someone, oh, UML's old, it's not good anymore, or they've had someone's had a bad experience with it. And it kind of almost like Chinese whispers of this thing is not valuable because they've heard someone who doesn't like this thing. And the other thing is, in recent years, there's been lots of developments in the tooling for creating diagrams. So maybe 10 years ago, you would have had to manually draw this diagram using boxes and lines, and it would take you ages. And if someone was to ask you to change that diagram after you've drawn 15 boxes and they want to add 2 boxes in the middle, it's going to take you half an hour to redraw all your boxes. So if you'd gone through that experience, it's quite painful. I used to do that. And if someone would request change to my diagram, a little part of me inside would cry because I knew that it was going to take me hours to redraw this diagram. And I guess the other one is education. Maybe people aren't aware of it, or they don't know how to get started with it. And if there's not that many people that are doing it, and I think it's got some popularity, but it's not widespread. It can be hard to know who to speak to get a better understanding of diagramming, where to get started, the types of diagram, that kind of stuff.
Mm-hmm. Yeah, the UML model is definitely something that comes to mind when you talk about diagrams, and maybe it's a little too popular for its own good. In the past, with the traditional software development cycles, do you think that the UML diagram was in itself reviewed? Is that something that had to conform to standards? And was that just for standards' sake, or was it something that they could take and convert to code, convert to something? Was there any particular reason that you see why there was so much rigidity in the UML style diagrams?
So I think with any standard, the whole point is it is standard. So you see a class diagram, for example, that represents classes in your code base that you create. And if I create one of my code base and you put them side by side, the class names will be different because they're different classes, but the actual structure of them and the way the lines are drawn and so on, those are standard in their model. And to a point, that makes sense, because if you didn't have a blueprint of what to go from, there wouldn't be so much value, because it's people wouldn't know what to do, right? Like all the diagrams they'd all be their own flavor of diagrams without the standard. But they went very heavy on the kind of notation, and I don't think they focused so much on the kind of use cases, which I think for me, I care less about what type of diagram someone uses and more about the information and the use case they're trying to convey. Kind of classic example is the other day, I worked with a colleague, and he was modeling classes. And if you were to follow to the letter, he would have drawn a class diagram. But he drew what's called an entity relationship diagram, which is used more for database schemas. But all he cared about was the names and how they related to each other. He didn't care about methods or properties, or in the case of a database, the columns. He just cared about the relationships. So for that use case, it didn't matter which one he used. So there was no real point in ruining that like hard work that he'd put in. You can obviously point out that, maybe in future, but for him, he got out of it what he needed. And the type of diagram was kind of less important, and the use case and the information was the important bit. I think that's what got lost a little bit.
Mm-hmm. Yeah, that makes sense. In the diagramming world, there's UML with its rigidity. Are there modern diagramming types that you are an advocate for, or you see people using? Are there names associated with it for specific types of ideas that you want to convey?
So there's UML diagrams that we've talked about a little bit, and from UML, there's 12, maybe 15 diagram types in total. I generally use 2 or 3 tops, because I think most common use cases can be covered by maybe 4 types of diagram, and that'll cover like 95% of your use cases. The 2 from UML, one we talked about briefly, which is class diagrams. So those are used for understanding classes and their dependencies. So you could draw class A, B, and C. you could show how one depends on the other, and you can show all the methods and properties on each class. And you can use those. I use them in 2 ways. I would say one is just understanding. So I'm sure we've all been in there. We're working on, let's say, a monolith, and you're trying to make a code change, and you're in a bit of code that you've not worked on before, and you go into your IDE, you find, let's just say, the controller, because it's like a HTTP request, and you're clicking through the files, and before you know it, you've got like 10 tabs open in your IDE, and you're trying to remember, which class talks to which class and all the dependencies. And sometimes it's easier to step back and just extract that information rather than trying to keep it in your head and just draw it out. And especially if you're pairing, you then have the same understanding, and you can draw that diagram together. You can validate that it makes sense. And then if you want to, you can go one step further. And once you've drawn that diagram, if you're making a code change that is not small, if you're doing, changing some text or changing tiny behavior, I wouldn't do this. But if you're doing a larger refactor, you can perhaps draw the class diagram as you'd like it to be when you're finished your refactor. And you can almost prototype using the diagrams and see if that makes sense. Because it's a lot cheaper than doing the refactor and then realizing, oh, I've now got like a circular dependency or something, because you haven't thought ahead. So it's about planning and understanding the class diagrams. The second one from UML is sequence diagrams. And these, I would say this is my favorite diagram, if I was to pick a favorite, because I think it's so versatile for so many use cases. There are 2 things that I visualize with it. One of them are like user flows. So understanding how a user uses your system. So if you have a login flow or a sign-up flow, and if you're in a, let's say a microservice architecture, you need to understand the steps that that user is going to take and which systems it's going to touch. So they're going to, fill out the form, click a button, some things are going to happen, and you can understand either A, how that currently works if it already exists, or B, if you're thinking about architecture, you can draw out the use cases of how the users are going to use your system so that you make sure you build the architecture that fits what your users are actually going to do. And the second one is for code flows. So you can have steps in the sequence that are for classes sending messages to other classes. And again, that's an understanding thing. I wouldn't use this for design, but if you're looking at the example we talked about earlier in the monolith, you could also use a sequence diagram to understand the messages being passed from class to class. Because obviously the class diagram gives you the dependency graph, but that's very different to the order of execution in the sequence diagram.
Yeah, that's a common thing when you're reading through code. You are trying to build this mental model of A calls B, B calls C, and then you have some state that's in C that gets passed on to Z. So if I'm hearing you right, sequence diagrams are one way to represent that in a more concise and easy to understand way. Is there anything else to it around sequence diagrams that you think aids understanding?
The only other ones maybe are you can also model almost like happy and sad paths in your system. So we talked a little bit about use cases and how people use your system. You can do the same for code as well. There are happy and sad paths. So you can kind of think about all the possible ways people could interact with your system and then how it responds. And similarly, that can be useful for when it comes to doing testing, for example. So it can be really easy to dive in, code your feature, and then you need to test it works, right? So you might write some unit tests, but also quite commonly you might do some manual testing, or depending where you work, you might actually have like a test engineer that does that for you. If you've drawn out these happy and sad paths, you can use that in that kind of conversation about, look, this is how we think it's going to be used. And the test engineer might think of more scenarios, but at the very least, they're going to appreciate that you've put some thought into the testing and you've got something for them to kind of start with rather than them having to work it all out.
I know talking about diagrams in an audio-only format is a little bit challenging. And in the book, you use an example company or an example service to aid understanding throughout the book in various chapters. So I think you talk about Streamy as a service. Can you just give an overview maybe of that? And then we'll use that as an example going forward in some of the more detailed descriptions of diagramming techniques and tools, etc.
So Streamy is a video streaming company. You can think of it like a Netflix. And they're kind of just getting started as a company. They're not 3 engineers in a garage, but let's just say they're 20 engineers, for example. So they're just getting going. They've got some funding, and they are going to build the next big video streaming platform. And to do that, we're going to go through the journey that Streamy would go through in order to build, I guess, their MVP. So that the minimal viable product, the smallest thing they can build, but the different steps of how I would approach that kind of greenfield, brand new project, and the diagrams I would use to help build the architecture that Streamy needs.
Okay, awesome. So starting with that, let's talk a little bit about more modern diagramming techniques. So you're in that room. How do you get started? Like, do you start with a diagram? Maybe you're collaborating on a whiteboard. How do you make use of these diagrams to convey ideas and come up with that architecture for this next generation streaming platform? Can you talk a little bit about that?
Yeah, so I'll give a quick overview of the different tools that are available. There's quite a few. Before modern diagramming came along, everyone would have used a UI tool. So something like Microsoft Visio, for example, that you have to pay for. There are open source alternatives like diagrams.net or draw.io is probably the one that everyone knows. It's free, it's open source. It's all in your browser. It looks very pretty. You basically drag and drop everything around on their kind of interface, but it's very slow. As we talked about earlier, if you need to update that diagram or change that diagram, it can be very time consuming and it's a maintenance nightmare. There are other problems with it. It will save in an unreadable format for a human. So if you ever used draw.io and if you went and looked at the save file, it's a huge blob of like XML from memory. You have no idea what's going on because it's written for a machine, which means you can't diff it. I mean, you could commit it to your project if you wanted to, but the next time someone comes to edit that diagram, they're going to load it into their Google Cloud. They're going to change the diagram and they're probably going to forget to update it. So now you've got a mismatch between what's committed in your repository. It's sat on your Google Cloud or my Google Cloud, and they're all out of sync. It's a bit of a nightmare. And if you want to put, let's say, an architecture diagram in your README, you need to export the image out of that program and store that in the repository, which now means your source of truth is disconnected from the kind of final artifact that you want people to read. Classic example is someone leaves the company and that diagram for your architecture is in their Google Drive. And I don't know all companies, but where I work, there's a choice when someone leaves of whether you keep their Google Cloud and it's given to someone else, or you just delete it forever. And once it's deleted, it's gone. You're never getting it back. So if that's your architecture or your documentation for your architecture, and that person leaves, your documentation is now effectively gone and someone's going to have to redraw that diagram. So as you can probably tell, I'm not a huge fan of the manual tools. They have places, if you're drawing a very complex diagram, or let's say you're presenting to executives and it needs to look really, really pretty, then sure, draw it in there as a one-off. But generally speaking, for the diagrams we're mainly going to talk about building software architecture, I would stay away from those. The tool that I think started the movement towards more automated tools, and the movement or the practice is kind of called diagrams as code, is Plant UML. And that's a tool written in Java. I think it was around the 2009-ish, I think it came out. And it basically allowed you to write markup that's similar to Markdown. So you might have A and then like a hyphen and an arrow to B. And then you could put like a label on it with a colon or something and give it a label for that line. And it would draw you a box of A to B with an arrow. And it would just render that for you. So you'd have to draw anything. And it's super simple to use. Problem with it though is that it's because it's written in Java, you can't run that anywhere. You have to run a Java server. You can obviously run it on your Mac or your PC or whatever. But it's a bit of a nightmare to kind of get set up with. So it has plugins that you can enhance its capabilities with. So out of the box, it offers you the UML diagrams I talked about, plus all the other ones that we haven't touched on. And you can enhance it with other types of diagrams that have come around since. But the new kid on the block is Mermaid. And the book focuses on Mermaid and is written in JavaScript, which is the main difference. The markup is remarkably similar. If you looked at the Plant UML and the Mermaid syntax, for the most part, they're pretty identical because there's only so much kind of innovation you can have in drawing these types of diagram because they are mostly UML diagrams. So there are standards associated with them. Because it's written in JavaScript, that means it runs in the browser. And because it can run in the browser, that means it's been widely adopted, which is the big, big, big selling point. I think Plant UML is awesome. Mermaid's also awesome. But Mermaid, the big one for me, is the adoption. So if you're using Jira, Confluence, Notion, If you're using the big one, GitHub, you can put your Mermaid markup in a markdown file on GitHub, and with no work whatsoever, when someone views that markdown file in their browser, GitHub will render that diagram for you. So that means your source for your diagram is committed in your project. Anyone wants to update it, they can just go in, edit the markdown, commit it, and it's updated. So your single source of truth for, let's say, your architecture is now in your project. It's stored. There's no getting out of sync, and the rendering is just done for you. And if you had external knowledge centers, for example, let's say you export that content and you host your own knowledge site, for example, that's easy to do in the build, right? You can just use the tooling that Mermaid gives you. It has a command line interface, and you can just render those diagrams in the markdown file before you render those HTML pages, for example.
Mm-hmm. And you get all of the versioning for free, it sounds like, because I was wondering, how do you do versioning in diagrams, and how do you keep track of older versions maybe? So I guess this gives you a very nice way to just version inside of your repository itself.
Yeah, exactly. You can basically just rely on the kind of the version control that everyone's got used to these days. That will version your diagrams. You can look at the old versions. You can't lose this diagram. It's, well, in this GitHub was to erase all the hard drives and whatnot, then we hope that doesn't happen. But that diagram's not going anywhere.
Nice. Can we take something from the Streamy service, some flow, some interaction, and kind of describe what this Mermaid or Plant UML syntax kind of looks like in order to visualize that? How hard is it? How easy is it? Can you shed some light on that?
Yep, I can do that. And I'm going to start where I would logically start if I was Streamy and I was doing this in the real world and I'd been given this greenfield project to do, and that's understanding the domain that Streamy is working in. For that, I would lean on domain-driven design and create a domain model that we can do using Mermaid.
For listeners, we have a full episode on domain-driven design, and I'll leave a link to that in the description.
So the way I approach domain-driven design, and I would listen to the episode for more detail because I'm not going to be able to cover it in this space, but I would think about the main entities that I, working at Streamy, care about. So the things we talk about when we're in meetings that the customers interact with, what are those? And we need to get this down, and we need to get the names agreed. Because one of the main kind of tenets of domain-driven design is that everyone speaks the same language. So if we're talking about, let's say, a title, if you go onto a video stream website, you watch titles. Some people might call them videos. It doesn't really matter what you call them. There's no right and wrong what you call something, as long as it fits your domain. There are obviously some ways to do it wrong. If you call it a desk, it's probably going to be very confusing. But as long as you give it a sensible name, that's fine. And your models also might look different. If you've got two sets of people and they both modeled Streamy, they'll probably come up with completely different things. So in your head now, you might be thinking about what Streamy looks like. It probably looks very different to what I'm going to describe. So we have our title. We're going to use a class diagram for this because I think it's the most appropriate diagram to represent the domain model. Although there's no properties, there's no methods, it's just a domain model, they're just names. But it's the closest thing in diagrams that represent a domain model, because when we convert this domain model into code, all these entities should exist as classes in our code base. So we have our title, that'll be a box, and connected, so with arrows going to this title, you might have different types. In UML, we call this generalization. In programming, you think of it like interface or inheritance, and you have types of TV show or short or film, and those are types of title. So they're extending title, if you like. And from title, a title might have seasons and episodes, for example. But where domain modeling and UML can help us is you need to understand how many of one thing relate to another thing. So a title, for example, if it was a TV show, it might have one season, it might have two seasons, so on. If it's a film, it'll have 0 seasons because it's a film. And therefore, on the diagram, you have things called multiplicity. And what this effectively does is tells you how many of one thing relate to another thing. So in the case of title and season, you can say a title has 0 too many seasons. And a season belongs to just one title. Because season 1 of Game of Thrones can obviously only relate to Game of Thrones. It can't relate to, I don't know, Dexter or something. It doesn't make any sense.
And how do you use this in Mermaid syntax or Plant UML syntax to represent?
So in Mermaid, each diagram has a type. So the first line in any Mermaid is the type of diagram. So in our case, it's a class diagram. If it's sequence, if it's sequence diagram, so forth. And for a class diagram, it's probably the simplest of syntax and markup that you can probably have of any diagram, because there's no methods and no properties. We just have the names and how they relate to each other. So it's super, super simple. So first line, class diagram. And then let's say we want to describe the relationship between a title and its seasons. You would put the word title, and then you would put, let's just say, 2 hyphens, and then another space, and season. And then if it was to render it, you would just get title, and you get season with a line between it. And that's as simple as it possibly could be. And if you then wanted to add in and enrich with the multiplicity, either side of those 2 hyphens, you would just put the multiplicities in speech marks. So 1 and 0 to many, for example. And Mermaid would take that, and it would just render these boxes and these lines.
It's interesting how this renders things from text, because sometimes when I'm creating it with UI tools, I'm kind of confused about how big certain boxes should be. Should my line be bold? Should it be really thin? Does it look okay? Does Mermaid take care of that with like default settings? And is there a way for you to change that maybe to make it visually more aligned to maybe your taste or the way that you want something to stand out?
Yeah, certainly. Depending on the environment you're in, you have different levels of control. So out of the box, Mermaid has its own rendering engine. So it will render everything in its default way and it will look nice. But if you wanted to change certain things, you can do that. So there's a type in Mermaid called a flowchart. And it's more like, if you've ever seen a flowchart, you have circles and diamonds, and it could be like, decisions and things. But it's their kind of generic catch-all for maybe things that don't fit into anywhere else. And in that example, you can change the direction, for example, rather than being top to bottom, it could be left to right. In the case of class diagrams and most other types of diagrams, you can use CSS styling to change how things look limitedly. And if you're using online, Mermaid has a live editor that I use a lot that lets you quickly create the diagrams, and it gives you kind of 2 panes. The left, you put your Mermaid markup, and on the right, it will just automatically refresh every time you change. So on that one, you can do these kind of simple things. If you were rendering them on your own website, you can do whatever you want because there are JavaScript kind of hooks for you to use. You can inject your own styling. But even with the kind of default and minimal, more locked down version of Mermaid, you can still change, the colors, the borders, all that kind of stuff. So you can kind of make it branded to your company if you wanted to do that. And Mermaid also comes with themes out of the box. So it has a default kind of, all the boxes will be purple, for example, but there are themes that make it blue or black or, dark mode that everyone likes these days, that kind of stuff. So it's quite versatile. And because it's open source, new things are always being added. I think, a new release comes out in a couple of weeks with new features and new things you can do.
Yeah, it's really powerful. I think this is very similar to what Markdown does, where you have the syntax and you have the extended Markdown syntax. And then depending on the rendering engine, you might even have other syntax types. Like, I know different rendering engines have different ways to render code blocks that I like. Some of them have syntax highlighting, some of them don't. So this is somewhat akin to that. And I guess what you're saying is that you can also override it similar to how you can with a Markdown rendering engine. That's very cool. Can you draw sequence diagrams that you mentioned earlier? Is it possible to use Mermaid for something like sequence diagrams, or maybe even just UML itself? Or is it just no UML, but we'll take some concepts, you have the boxes and the lines without all of the rigidity. Is that the idea? Or can you also get all of, UML sequence diagrams and just plain simpler representation of diagrams?
Yeah. So I think you can do both depending on what you're trying to do. So if you are trying to build or understand a sequence, I would always just use the sequence diagram because it's going to handle the layout and the rendering for you. So in a sequence diagram, you have what are called lifelines, and those are the individual nodes that messages are passing between. So let's say you had a flow for a user being able to sign up to Streamy and create their account so they can view titles. You might have a little stick figure. So in Mermaid, you have what are called actors and participants. And all that means really is it changes the little kind of icon from a box, which represents normally like a system or something or a class, and a stick figure, which represents a person. So you might have the browser, and you have a line from the browser to the sign-up service that is retrieving the HTML for the sign-up page. And then you'd have a dotted line back, because in sequence diagrams, commonly you have a dotted line to show responses and a solid line to show requests. So you can easily differentiate between the two. And that will return some HTML to the browser. And that's kind of like the first interaction in the sequence diagram. Now the user is going to submit their details to the sign-up service, which will be a post request. So on the lines going between, you can put very simple kind of notation to explain what's going on in these interactions. You definitely don't want to be putting, your JSON payloads in there. These need to be like nice and high level. It's a post request and it's hitting this endpoint. That's simple. Then when it gets to the sign-up service, it might, you might want to call out some of the stuff it does. So let's say you're working with microservices, you have your sign-up service, and let's say you have a user service that stores your user data. The sign-up service might make a post request to the user service. So then you have another line to another kind of lifeline, and that might return a 201 to the sign-up service, and then that might return a 301 to redirect the login page to the browser. So then you have a series of interactions between different participants. And one of the really nice things you can do in Mermaid is you can add numbers, which sounds not that powerful. But if we're talking about a sequence that has, the one I described, for example, in the book, has 9, 10 different interactions on it, rather than someone trying to describe, at this point, they can just say, at number 6, what's happening here? Can you explain this? I don't understand this. It's really quite a powerful tool just to aid general collaboration, for example, make it easier to collaborate. As for diagrams outside of UML, Mermaid has a kind of catch-all that I mentioned earlier called flowcharts. And those are kind of super versatile, not UML, just general flowcharts where you can draw pretty much whatever you like, and you can change the shapes of the boxes. So you can have, square boxes if you're doing a service. If you need to represent a database, you can have like the little cylinder that's commonly used on diagrams for a database. If you're maybe drawing almost like a business rule company I used to work at, it was a loan company. So they gave loans to people. There was a decision engine with hundreds of rules. And each rule could be defined as a flowchart, which is you take a data point, you might have an arrow to a diamond that says, if this data point is greater than this, then go down this path. If it's less than this, go down this path. And it's a really nice way of using a simple flowchart just to visualize business rules. And if you were building this decision engine that's got hundreds of rules, as an engineer, you can just go and look at the flowchart for the rule that you're currently coding, and it's all there for you. All the use cases, all the business logic is in that flowchart. One of the other ones that I don't think we've touched on yet is if you want to document your architecture, I always reach for something called the C4 model.
Mm-hmm. Yeah, let's dig into the C4. Can you describe what that is? And then we'll come back to the Mermaid, how to represent there.
So the C4 model is a way to model your software architecture. It was created by a guy called Simon Brown. You may have seen him speak. If you go to conferences and things, he's quite kind of common on the calendar of conferences. He's probably been to one you've been to. And you can use it to design, document, model your architecture. And it's one of those long-lived diagrams that in every system that I work on, it will have a C4 model in it. And what it does is it takes what I call a focus system, so the system that you are responsible for as a team, and it helps you document and understand the architecture for that system. So in the middle, you'll have your system that you own. Typically above it, you have the dependents, and these can be systems or people. And below it, you'll have the dependencies, so any downstream systems that you use. Within C4, the name comes from 4 diagrams. So C4, 4 diagrams. And they all mostly begin with C. The first one, which is the one I just described, is the system context diagram. And that is the kind of 50,000 foot view of your system. And it just it's completely non-technical. There's no protocols, there's no databases. It's purely describing almost like the business interactions between the different systems. So in the case of Streamy, you might have a premium member, for example, and you might have, let's say, a service, because we're going to build microservices, for example. There's the listing service, and that listing service contains all the data and all the information for all of the titles that Streamy offers. So anything in your architecture that wants to get information about a title, it reaches out to the listing service. But obviously, the person, the customer, also kind of interacts with this, right? Because they're going to want to view the titles. So maybe as a front-end component to it, that renders the titles to the user. Now, that listing service, to do its job, might break down and call other systems. Let's say, for example, reviews. Let's say you review titles. Maybe you want to store your reviews separately for some reason in a review service, or you want to search the titles. And because searching is very kind of bespoke, let's just say you want to use Elasticsearch, you might have a search service, right, that's completely separate for searching the titles, for example. Now, you can draw that on your C4, like I just described. And I've shown this to product managers, stakeholders, completely non-technical people, and they're able to digest, understand what it is that you're building. And that can be really useful to help explain what you're doing. And the classic question of why did this take so long, or why is this taking so long? You can kind of explain to them why you're building it this way from a completely non-technical view. I won't go through all of the layers of the C4 model because I actually mainly focus on the first two. And the second one is what we call the container view. And this is then getting into the technical layer. So you have your system context for the high-level view. And then if you want to zoom in, so engineers typically will want a bit more information than just a box that says, this is the service. They might want to know how this service is put together, what containers it has. So let's say in the listing service, you can almost think about, on the first diagram, double-clicking the listing service, and it zooms in, and it kind of splits out all the single deployable units that make up your service. So when you push to master, it deploys what do you need to run. Let's say, as part of the service, you have a mobile application, and also you have a web application. So people can access your listing service via mobile, via web, and for whatever reason, you deploy those together from the same repository. And maybe because calls to the get titles is expensive, maybe you have an in-memory cache or something where you hold these titles in Redis, for example. And these would be three separate containers, almost in like a boundary of your system that you could document. And you still have your downstream services that still call, but it's just, you can almost imagine in the middle, you have like a box with dashed lines around that show the boundary of your system, and anything in that boundary belongs to this service, and you can dig into it further and further and further. And as you go through the model, it digs further and further. But I've never really needed the next two, which briefly are components and code, with components being the high-level modules that make up each container. And one level deeper is the classes in those components or modules. But those, even if you hear Simon speak, he will generally say those are there to enable the ability to do it. But generally, the first two are all most people need, especially if you're building microservices. I would say components maybe if you're in a monolith, because it better represents your architecture.
You may be able to represent different modules within a monolith as a container, perhaps. Is there a difference between the container and component in terms of the representation? Because once you zoom in one level deep, is it just boxes that encapsulate what it's doing, describes it, and then have connectors to other similar containers or components?
So if I was doing the C4 model and I was working in a monolith, what you would basically have on the system context is you probably have a stick figure or whatever of a human, and they are doing all of their interactions with the monolith, whatever they're doing. In the case of Streamy, they're viewing titles, they're reviewing titles, they're searching titles, updating their account, they're doing everything. You would probably have to find a general way of describing this because you can't list everything they're doing. Otherwise, this line is going to be a long line. But then if you, like I said, again, I think of it like double clicking, zooming in on that monolith, and you would look at the container, you would perhaps maybe have a single web app, and maybe it's got a database hanging off it. But I don't think it fairly or accurately represents your architecture, if it is a monolith, just to have that one container. Because you might think, this architecture is super simple. They've got a web app and they've got a database. But when you look at that monolith, if it's a 10-year-old monolith, and depending how that monolith is arranged, because it might be the classic big ball of mud, it's not arranged in any logical way, then you're probably, in terms of diagramming, I don't think you're going to be able to do it. To be honest, I don't think, mostly because it's going to change too much because it's the monolith. And second of all, there might not even be clear components. It might just be all over the place. But the likes of Shopify are pushing and promoting modular monoliths, or majestic monoliths, depending which one you prefer, where within a single monolith, you have separate segments. They have different names for them, but in Rails, which what they use is Ruby on Rails, they're often engines, and those are akin to modules. So they're self-contained segments of the code base within the monolith. So you might have a payment module, you might have a title module for viewing the titles and managing the data for the titles. You might have a user module, for example. And if you have that monolith and that nice structure, I think you can make a component diagram that shows up the high-level components that make up your monolith. And that's akin to, each module, if you were in microservices, each module would probably be a microservice. So I think using the component diagram for a monolith gives you a fair representation of your architecture, versus if you are in microservices, the container level, it's just enough detail, because when you zoom in, assuming you're doing microservices, nicely sized services correctly, all of the code in there should be kind of described by your service, and the kind of underlying components probably aren't too important, at least to have in your README.
Makes sense. Going back to Mermaid as a tool for representation, how do you do C4 with Mermaid? Does it give you that visual aspect of zooming into a particular box that expands into a more detailed representation? Is it that way, or is it just different diagrams?
That would be nice. I have a feeling you could possibly, if you had your own website where you were deploying these to, like an internal knowledge base, you could probably write some JavaScript that allowed you, when you clicked on it, it maybe, changed the image or something fancy, or scrolled to another point on the page. But if you were using GitHub, because I just like GitHub to do all the work for me, really, I would just have, an architecture markdown document. And at the top, I would, write a brief introduction of a high-level view of the architecture and what it does, because I think diagrams on their own are super powerful, but some words are also, to supplement, are also helpful. And I would have the system context diagram. I would put a link to the C4 model. So if people want to read what the C4 model is, I'd put a link to the C4 model. There's a website for it. It's very good. And then below that, I would put the container diagram. So they're both one below the other, and people can just both view both together. I think it would be really cool if it did what you said and you could zoom in them. But yeah, Mermaid hasn't quite got there yet. Maybe it will. As for creating them in Mermaid, I create them personally in flowcharts. They're really easy to make because they're quite simple diagrams. For the container diagram, when you're making the kind of boundary for your system, within flowcharts, you have subgraphs, which are like diagrams within diagrams almost. And using that, you can then make your nice little box for your service. And then anything inside the box is what you deploy as part of your service. Mermaid has experimental support for the C4 model. I believe at the moment it only does the system context. I don't think it does all of them yet. They're looking to add it. And it uses the same syntax, the Plant UML plugin for C4 users. So they've just imported it. I'm not a huge fan of the syntax. I think it's quite ugly. So I don't really enjoy working with it. I think it's a bit too verbose. So I'm going to stick with the flowcharts now, at least until maybe Mermaid picks their own syntax for it, because it is still experimental. So we'll see where that goes. But for now, I use the flowcharts and it works. It works super well.
I want to switch gears a little bit into more informal diagramming techniques, maybe just whiteboarding. Do you have any particular approach that you take towards whiteboarding and diagrams as you would with respect to something that you're building on a PC, putting that into a document?
I think the main one, the popular one at the moment, is a tool called Miro. That's what I use generally for any kind of whiteboarding. Most recently, I did a session on event storming, which is probably maybe going to be covered in your DD talk. I don't know if they're going to talk about event storming, but it comes from domain-driven design. And before COVID and before everyone, or not everyone, but before remote working was everywhere, when people were in offices, event storming would be done with sticky notes. So I'm not going to explain too much about what event storming is because we'll be here for a long time. But It's a way of understanding the kind of key events that happen in your domain. And you would each have stickies, and you would write on your sticky, you'd stick it on a whiteboard, and you'd basically have, by the end of the first kind of section of event storming, you would have a big line, there's a chronological line of all the events that happen in your system. Obviously, in a remote world, that doesn't really work. I've seen it where people have kind of put the camera and the people in the room have put the stickies up, and then the remote people talk to the people in the room about, hey, can you put this sticky here? And it's a nightmare. So most recently, I did it on Miro, which is basically just an online whiteboard. You can draw all sorts of things in Miro, but because it's visual, it's not obviously suitable for the diagrams we've talked about with adding them into GitHub and so forth. But for collaboration and brainstorming and coming together and collaborating on something like event storming, I think Miro is probably the best tool now, and you can see what people's cursors are, you can see what people are editing. It's quite powerful.
Nice. And with respect to code generation, I want to see if there are tools and techniques to generate code or some artifact starting with diagrams. I think in the UX world, people use wireframing tools where you draw something on a tool maybe, and you might get a static website or a static page that represents it. So are there techniques like that for generating maybe components, modules for a service? Maybe it's a monolith or something, and then you can draw out something in Mermaid or some other tool that generates the required stubs for what you're trying to build.
I think we're not quite there yet for most things like that. So there's the reverse. So if you're working in a statically typed language, a really common thing you can do in, let's say, Java or C# is you can export a class diagram from your code base. If you're working in a monolith, you're probably not going to be able to export it because you're probably not going to have enough memory, but you can export segments of it perhaps, and it will generate your class diagram, not in Mermaid or anything, it will just give you an image typically. So I think that's been around for quite a while. I think the one that is probably, I don't know if you can do it yet, maybe you can, but there's a diagram called an entity relationship diagram that we talked about earlier, which helps you represent database schemas. And on an entity relationship diagram, or an ERD for short, you have the tables, how the tables kind of relate to each other, and the kind of columns, keys, and so on. So if you were designing, let's say, Streamy's underlying data, which is often very different to your kind of code classes, you might want to do some upfront design with an ERD so that everyone understands the kind of the database and you can visualize it and make sure all the data is, if you want to normalize it, for example, you could see if there was any duplication or anything you could improve. It's easy to get feedback on the design of that database from, maybe an architect or whoever, you can get some feedback on the diagram before you build it. Once you've deployed it and you've got data running through, it's really hard potentially to then go back and change that. And it's also a huge waste of time. But because of the way you write ERDs, I could easily see them, once you've agreed a design, converting that into SQL. Because the way you write ERDs is very close to the SQL definitions of when you actually create them in your code. So I could see that one definitely being a thing, if it's not already a thing. I don't know if it is. Maybe there are tools out there. The other cool one I heard about recently, and I'm not sure how long it's been around, but in AWS, you can, I think it's called Cloud Formation Designer or something along those lines. And you can basically draw diagrams in AWS's console using the products. So you could draw an EC2 instance, an S3 bucket, Postgres database, whatever you want, and the diagrams, and it will generate you the cloud formation for that architecture. So you could collaboratively convert your C4 model into infrastructure as code if you're using CloudFormation or Terraform. Obviously, in this case, it's AWS, so they're going to give you CloudFormation. But you could draw them in that console, and it would give you the code, the underlying CloudFormation, that you could then just put straight into your deployment pipeline and deploy it. So that's another example of turning a diagram into code. I think that's probably the area where diagrams has some area for innovation, I guess.
Mm-hmm. Yeah. Going in the reverse order is maybe the last thing I want to cover. Starting with a complicated piece of software, a code base, maybe I join a new company and there is this massive code base that I want to get familiar with. Starting with a diagram would be great, but more often than not, they don't necessarily have a diagram, or maybe it might be stale. So starting from the code, is there a good way to generate some sort of a diagram? Are there any tools to learn and onboard into a new project or a code base?
So I think the ones we've talked about already, assuming you can commit them, and when we talked about GitHub automatically rendering Mermaid diagrams in Markdown, the two key ones for me that I have in any repository is the domain model. I think if you don't understand the problem space you're working in, you're probably going to hit some problems. And you can put that, in your README, or it can be in a Markdown off your README. And the C4 model is the second one I would always have. Any new joiner that joins, you can just point them to those resources, and you can enrich the diagram with some, with words. It's not like, I'm against words. Definitely put some words down alongside your diagrams. But that's a really good way for them to get up to speed with the problem space you're working in and the architecture. The code is a trickier one because it really is going to depend on monoliths versus microservices versus kind of where I work at the moment, which is it's the classic of everyone hated monoliths. They went to very far on microservices, and then they realized, this has got some other problems. So, we're kind of working our way back to somewhere in the middle. People like to call them like macro services or whatever you want to call them. So commonly I might have like a component diagram, for example, from the C4 model that lists the high-level modules for that kind of medium-sized service, for example. And then at least they understand the high-level modules of how that code is arranged. The trickiest thing with code is documenting it. I wouldn't do it too much because it's so fluid and so easy to change. Like you could draw the diagram and it could be out of date the next week if someone, comes in and rehashes everything, or even just rehashes part of it, refactors, sorry. And there's nothing worse than out of date documentation. That's worse than having no documentation at all, almost, because they've gone and read the documentation, they've spent some time reading it, and then they've gone to look at they've checked out the code, cloned it, and it's completely different, and they've just wasted loads of time reading this document that wasn't useful. So for code itself, I would be cautious about documenting it, which is why also I talked about short-lived versus long-lived, where the long-lived diagrams, the architecture, the domain model, those I commit because they will change. They are living documents. They should be updated, but they don't update. How often do you significantly change your domain model or your architecture? It might be once a quarter or once a month, but it's not going to be so much it becomes a burden or a time sink. Versus the short-lived, which is class diagrams or sequence diagrams. They're used to understand something in that moment, but they're probably rapidly going to become out of date. I think the only overlap, or the one that's applicable in both, is perhaps sequence diagrams. If I was doing, let's say, an architecture decision record, which is a document you can write to rationalize why you're making an architecture decision, I think putting a high-level sequence diagram of the flow that you're building for this architecture, super useful, and is probably unlikely to change again. So that's one that does both. But yeah.
It's great advice. And I think with that, we'll end the show. Ashley, thank you so much for coming and talking about diagramming and some of the tools to really build your diagrams and make it easier to maintain them even. Thank you so much.
No worries. Thank you for having me. If you want to learn more about my book, Creating Software with Modern Diagramming Techniques, on how you can use it to build better software, it's available from all the main retailers. It's available on Amazon. Feel free to check it out. Thank you.
I'll leave a link to Ashley's book in the links so you can learn more about diagramming. Thank you so much for coming. This is Akshay Manchale for Software Engineering Radio. Thank you for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.